Alright everybody, I just recorded a video and it failed to save, so this is going to be the slickest, fastest review with no wasted time because we're just going from my notes right here, haha, but you have to wait to see those. I know you're going to be very excited and anticipatory about that. Alright, topics for tests very quickly. We're going to go through what you need to know for the tests and what you can do to prepare, and just keep at the end of this you'll have sort of a sheet that you can look at the image of if you need to when you're reviewing. And here we go. Alright, so first and sort of simplest, balancing equations. I don't know that anybody's having a whole lot of trouble with that, but if you are, I guess let me know. We've done a lot of practice, so you guys got to let me know if you're having trouble. All right. Like my camera's having trouble getting focused on this. Come on, dude. There it goes. All right. Balancing equations. You got plenty of practice on those. Oxidation states. Okay, you got the email with the rules. Okay, and I thought, as I read back through those, I just wanted to be clear that next to fluorine, I said it's -1 no matter what, unless it's in F2, okay, where it's a lone element bonded with itself. Then it's 0 oxidation state. Okay, that's always the case no matter what. Okay, so I just wanted to make that clear. I think that was clear, but I just want to make sure. All right. Knowing oxidized or reduced, and which one is the oxidizer and the reducer, or the reducing agent and the oxidizing agent. Okay, so very quickly, if we have H2 and O2, and that goes to H2O, what are our states here? These are lone elements, so that's 0. This is 0. And we've got a -2 for oxygen, as our rules say it should be. And that gives us a +1. 2 plus 1s make a 0 with a -2. So everything follows the rules, easy peasy here. Okay? All right, so H goes from 0 to +1. O goes from 0 to -2. If this you go positive, that means you're losing electrons, which is what? We have oil rig. Lose electrons, you're oxidized. Gain electrons, reduced. Therefore, hydrogen causes oxygen to be reduced, which means hydrogen is the reducing agent, and oxygen is oxidizing, unsurprisingly, agent. Okay, that's why it's called oxidizing, because oxygen's often the one doing it. All right, you can read more in your book, whatever, get familiar back with that as you need to. Okay, we want to be able to write reactions properly. Okay, that page 170, what did we say it was, 172? Yeah, page 172 table. Okay, just like we did on our quiz here a second ago. There'll be a couple of those. Okay, then we need the types of reactions. Okay, you need to know those. A plus B goes to AB. What's that? That's synthesis. Things are synthesized, they're created. Take your parts, make it into a more complex whole there. AB goes to A plus B. Dead bodies decompose. They fall apart. This is decomposition. Okay? AB plus C goes to AC plus B. One thing has been replaced, so that's single replacement. Okay. AB plus CD goes to AC, AD plus BC. Both of these swap places, B and D swap places, and that's double replacement. Then you have combustion, which you can look up if you can't remember what that is, and acid-base neutralization, which makes a salt and water. Okay? All right, so along with that is the activity series for metal. Okay, and how will you have to use that? You will just have to tell me whether a reaction goes forward or not, just based on the activity series of metals. Okay, just like you guys did in your homework, it's very simple. You'll be provided the table. And just like in the book, I'm not going to tell you which one's more active. You need to know lithium is more active and gold is the least reactive. Okay? All right, so then we got a couple of things that are very related here. Stoichiometry. And with that, we have limiting and excess reactants. Okay, we've got percent yield and theoretical yield. Okay, we're about to work through some of these right here. Okay, and I want to be free to write like he has kind of in that section 7.3 of the homework. We have really kind of turned a corner into useful chemistry at this point, in the fact that we can take natural language. So I mix, blank grams of magnesium chloride with such and such acid, and it produced this and this. Or maybe we can even predict what it produces based on the activity series and on, I don't know. We can do a lot with this stuff that we couldn't really before. And for sure, if we know what the reactants and products are, we can predict how much should be produced and how well we're doing at producing those based on stoichiometry now. And so these are huge leaps. And I hope you guys are excited about being able to do that and feel good about the work you've put in to really kind of start to understand chemistry in a very functional and useful way. There's a lot of rules, a lot of weird stuff that's maybe not apparent the first time you look at it, but as if you study chemistry more, you guys are going to really understand it a lot better, and things are going to click into place even more than they hopefully have already. But anyway, so I want to be able to write a couple of things. I want to be able to say things like magnesium chloride was mixed with da-da-da-da-da. Okay? And you guys know, because magnesium is in group 2 and chlorine is over there in the halogens, that this is typically a +2 and this is a -1, and so that this has got to be MgCl2. Okay? All right, also, I want to be able to use hydroxide. So I want to say sodium hydroxide. And you know that that's Na, OH. Na is a +1, OH is a -1, and that's the compound it forms. Okay, so we don't need any subscripts there. Okay. This is the only polyatomic ion I'm going to ask you to pull back out of your memory. It's so common. I'm going to expect you guys to know that, and to know that it's a -1 charge on that one. Okay. If there's something else I need to tell you, I will give you the ion and the charge on it. Okay. I haven't written the test yet, so I'm not sure what all is going to be on it. All right, and then finally, you need to refresh yourself on this. You see this. What does that mean? It means the common oxidation state that it's taking is 3. Okay, so we know that oxides are, we know we've got iron oxide, right? This is going to be a -2 because that's what oxygen does unless we hear otherwise. And this is a +3. So what's that mean? That means that we got to have 2 irons and 3 oxygens to make the whole thing equal up to be a 0. All right, so it may or may not be iron 3 oxide. It might be copper 2 chloride. Okay, you need to know that that's copper 2 chloride, means it's a +2 and a -1, so that gives us that. Okay, so refamiliarize yourself with some of those things. Okay, because it doesn't do us a whole lot of good to learn all that and then just kind of pack it away in the closet. We're not going to do that. Okay. All right, so let's flip back and let's put all this together and be very clear about what I want from you guys in your skill set. Okay. I want for you to be able to do on your test without anything but a periodic table. Yeah, so you will have activity series and that blank periodic table we've used in the back. We've used in the past. Okay, that's what you'll have. All right, so let's look at number 20. Okay. Iron ore contains iron 3 oxide along with several other substances. It's reduced by heating it to 1250 in the presence of carbon monoxide. The reaction produces iron metal and carbon dioxide. What's the theoretical yield in kilograms of iron from this reaction if 2.5 times 10 to the 4th kilograms react with excess carbon, and that should say monoxide, because he just told us that's the reactant. Okay, so first thing we got to do is we got to write equation. Then we're going to balance equation. And then we're going to do stoichiometric calculations. Okay, so let's write our equation. What do we have? We said it's iron 3 oxide, like we were just talking about a second ago. That's that. And what did we say? Carbon monoxide, mono, 1, goes to iron ore and carbon dioxide. All right, so how are we going to balance this? Okay, I want to get those oxygens to where they can be doubled easily, because we got that going on here. So I'm just going to, on a whim, I'm going to kind of put a 3 there, because then we got 3 oxygens and 3 oxygens. It makes it a little bit easier in my mind. And I'm going to put a 3 here. Does that get us where we need to go? 3 C's, 3 C's, 6 oxygen, 6 oxygen. The only thing left is to balance the iron. Let me do that. Okay. So now we've written our equation, balanced our equation. Oh, wait, have we written our equation? No, we have not, because we needed to put here and here. That's a very important part. You just mix these two together without any heat, nothing's going to happen. So we need to put our delta right there. Okay. And if we were going to be real nitpicky about it, we could do this with the gases: solid, gas, Solid. I'll be very clear if I want you to do that, okay? All right, so then what do? What's our next thing? Do stoichiometric calculations. Okay, so now we're going to treat this like it's a conversion problem. We got 2.5 times 10 to the 4th kilograms. Right, so what are we going to do? 2.5 times 10 to the 4th kilograms, Fe2O3. And I recommend you keep this on it because it's easy to get lost in these, okay? And I want you guys to make sure that you have everything cancel out. Okay, and I'm going to say 1 kilogram of Fe2O3 is equal to 1,000 grams Fe2O3. Okay, gets rid of kilograms. All right, now we need to get into the stoichiometry. Remember, we're going to do mass to mole to mole to mass. And like I said in my video the other day, sometimes you only got to go from there to there. Sometimes you only got to do these because you're given moles and you're going to moles. Okay? Sometimes you got to go from there to there. And sometimes you got to go all the way. Okay? But this is always the pattern that we're following. All right, so right now we just converted units. We haven't done any actual. Now we're going to get into moles. So we're going to say 1 mole Fe2O3 is going to be 55.8 times 2 plus 48. So 16 times 3 is 48. 55.8 times 2. Whatever that's going to be, it's going to be grams Fe2O3. All right. So now, what do we got? We got to go mole to mole. What does that mean? That we're going to use our stoichiometry now. We're trying to end up with how much iron do we make? So we're going to say 1 mole, we're going to do 2 moles of iron is going to be equal to 1 mole Fe2O3. And when I say equal to, I mean 1 mole of this produces 2 moles of that. So that's this ratio right here. Okay? All right, so then we're going to say 1 mole of Fe is equal to 55.8 grams Fe. And specifically asks us in kilograms. So we need to get back to that. So we're going to say 1,000 grams of Fe is the same as 1 kilogram Fe. I think everything cancels out. Grams FeO2, grams Fe2O3, moles, grams, and we're left with kilograms. So we have 2.5 times 10 to the 4th times 2 times 55.8 over 5.8 times 2 plus 48 in parentheses here times 1,000. Oh yeah, sorry, I forgot to carry this 1,000 down. Okay, but you can see that cancels and cancels number-wise. Okay, and then we will multiply those together and we will get 2.79 times 10 to the 6th over 159.6, and that will give us 17481 kilograms. You can check my math if you'd like. And that's 1.75 times 10 to the 4th kilograms of Fe produced. Okay, so let's take it one step further. That's our theoretical yield. Okay, that's what it's on paper. Okay, so what's our limiting reactant here? Well, it tells us that it's in excess of CO. So this has got to be our limiting reactant. because no matter how much we react, we've got more carbon monoxide there to react with it. Okay. So if we're told one is the excess, the other's got to be the limiting. Okay. Now, in full-on, college chemistry, you might have to actually put in your moles and figure out. And he may have actually asked you to do that here. He does actually on 21. You had to figure that out. You have to look at the moles, and whichever has the least number of moles for the stoichiometry is the limiting reactant. Okay, but I don't think I'm going to ask you to do that. I'm just going to tell you which one's limiting and which one's the excess. Okay, or I'll say this is the excess. I may ask you what's the limiting, but guess what? It's just the other one. Okay, so let's just take this one step further and say, what's our percent yield if we only got 1.71 times 10 to the 4th kilograms? Okay, well, percent is always the part of a whole. So what's our part? 1.71 times 10 to the 4th. And the whole would have been 1.75 times 10 to the 4th. Okay. And when we put that in our calculator, we get 0.977, which goes to 97.7%, which is our percent yield. Okay. All right. Now, sometimes if you're sloppy in the lab, your percent yield can be over 100%, which is obviously a problem. Usually means you haven't dried your sample well, or you've got other impurities in there. And that's something we'll talk about in the lab. But yeah, so that's that. Make sure you go through the end of the chapter. Plenty of practice there, guys. Plenty of practice. From 16 all the way through 28. Those would all be valuable for you to do. If you guys get stuck on any of them or whatever, let me know. I'd love to work through one and send you a picture of the work. It's no problem. But I think you guys have had plenty of practice and plenty of shown how to do it. If you put in the time to study, I think you're going to be okay. I would suggest a little bit on Saturday, a little bit more on Sunday, and a little bit more on Monday, except for the Sabbath. So maybe not very much at all on Sunday. All right, good deal. Let me know if you have questions, and I will see you guys next week.